Alright, so this is possibly the last problem I'm gonna solve. It's the binary search so far. And so this problem is very similar to the previous one. It's also a rotated array. And so basically the array is something like this. As you can see, there are two sub-arrays. There are two sorted sub-arrays, like the first sub-array and the second sub-array. And note that all the elements in the first sub-array should be larger than all the elements in the second sub-array. And note that in some special cases, if there's no rotation at all, or it has been rotated to enough times, there may just only be one array, just one total sorted array. So the goal is to search for a certain element, and if the element exists in the array, we should return its index. Otherwise, return -1. Alright, so the idea is quite similar to the previous one. Like first we just wanna of course we rule out the corner case in which there's only one element in the array, and then in our searching, just in order to avoid some possible errors, we just stop searching if there are only two elements left in the search in the searching range, and then we just can compare them to the target respectively, and that should be fast. So with that said, we only wanna, so at least there should be three elements in our searching range. So we first start the left from the very beginning and the right from the very end, and then we calculate the mid. So this is the mid 17, and we first just want to see if this is larger than the target or not. If this is larger than the target, and also we want to know, like, if the target is in the possibly the first array or the second array. So we just compare the target with the first element, and if the target is larger than the first element, then it's in the second array, and if the target is smaller than the first element, then it's in the sorry, my bad. When the element is smaller than the first element, then it means that the target is in the second array, just this part, this smaller part. If the element is larger than the first element, then it's in the larger part, like the first sorted array. So let's just do the coding, and we will go through other conditional statement while I'm coding it. So if num.length is smaller than 2, then we just see if num0 equals to target. If so, return 0. Otherwise, we cannot find the target, then we return -1. And then, as usual, we want two indexes. So left equals to 0, int right equals to num.length -1. And then while left is smaller than right -1, we wanna go out of the iteration when there are only two elements or one element left in our searching range. So while left is smaller than right, and then we calculate the mid as usual. Right, and then we first want to see if the target is in the first sorted array or the second sorted array. So if the target is larger than the number, then it's gonna be in the first sorted array, and then we really wanna see if our mid is larger than the target or not. So if num's mid is larger than the target, so if num's mid is larger than the target, and also this means that the mid is also in the first sorted array, and note that our target is also in the first sorted array, so this is just like a normal, just very basic binary search, right? We just look at the left hand side of it, and else if nums mid is directly equal to the target, then we can just return mid. And else, so this way, if nums mid is smaller than the target, if nums mid is smaller than the target, then we need to say like whether our mid is in the first array, whether for instance, let's see, like our target is this 15, and it's in the first sorted array, and now we know that our nums mid is smaller than this 15, then our nums mid can either be like also in the first array, but on the left hand side of target, or on the right hand side of the target and in the second array. So we wanna check whether it's in the first array or in the second array. So if nums mid is larger than the target, then which means that if nums mid is larger than the first element, then it's also in the first sorted array, then it's just like a normal binary search, right? But else, if it's in the second sorted array, then actually we need to look at the left hand side of the mid of the current mid element, right? And we just repeat the same logic here. So else if, so see, this else is matched with this if. So if the target is not larger than the nums 0, if the target is not larger than nums 0, which means that our target is in the second array, then we want to say, so if our nums mid is larger than the target, and there are two cases, since now nums mid is in the second array, target is in the second array, for instance this 5, and we know that our mid element now is larger than the target. For instance, it can be this 7, or it can be any element in the first sorted array. So we wanna separate the cases. So we wanna check if nums mid is larger than nums 0. So if it's larger than nums 0, that means that it's in the first sorted array, but our target is in the second sorted array. So with that being said, we need to look at the right part of our right hand side of our current mid. So left equals to mid plus 1. And else, if our mid is also in the second sorted array and it's larger than our target, then we need to look at the left hand side of our current mid. And else, if our nums mid is directly the target, then we just return mid. And else, so now our mid is smaller than the target. Our mid is smaller than the target, and also since we know our target is in the second array, which means that our mid cannot in the first array, since all the element in the first array is larger than any of the element in second sorted array. So this means that our current mid can only be also in the second sorted array, and it's on the left hand side of target. So in the next iteration, we need to look at the right hand side of our current mid. And now it seems like we have finished the iteration logic, and then we want to just go through the final check, since there are 2 or 1 final elements left. So we want to check if nums left equals to target, then we return left. If nums right equals to target, then we return right. And in other cases, we just return -1, since we have we have been running out of all the elements in the array, and we still can't find an answer. We still can't go into the return. So that tells us that the target does not exist in the array. Missing return statement. Missing return statement. Wait. My bad. I just put. Yeah, I should just put those things outside of the while loop, not inside the while loop. Okay. Small issue. No worry. It seems like we have going through a infinite loop. So let's see what's wrong here. So if the target is larger than the nums mid, else if target is so what if the target is directly nums 0, right? What if the target is directly just nums 0? So we will go into this loop. It looks good, and if nums mid is larger than the target, let me check for a while. If nums mid is larger than nums 0, I see. This logic may not be correct, since let's go through this again. So in this else, this means that our target is smaller than nums 0, which means our target is on the second sorted array. And in this else, which means that our nums mid is smaller than the target. So we are also in the, so nums mid is smaller than the target, and target is on the second sorted array, so our nums mid must also be on the second sorted array, and also the target is on our right hand side. So actually we need to go to the right part to search the right hand side in the next iteration. Right, so this problem, yeah, it looks good now. Wait, so we also get an arrow here. So let's see what happened. So we start with 1 and 5, left on 1, right on 5, and then the mid should be 3. And since our target is directly nums 0, and if our target is nums 0 and then we are larger than our nums mid 1, not nums mid now is just 3 is larger than the target, and also it's larger than, so we left. So we're kind of, since this is the case, we have not considered if the target is just the first element. So here we want to just write it more clearly, just clearly target is smaller than, and then else. This else means that our target is just nums 0, so we can just return 0. Alright, just run a test and then we can just submit. Right, so we're done here, but our space complexity is not very ideal. I guess it's because we just used so many nested ifs, and but I think it's acceptable since we only used a finite number of additional spaces. So it's gonna be, so space complexity is O(n), and clearly our time complexity is gonna be, time complexity is O log n, right? Since this part is O1 and this whole huge while loop is log n, and this initial corner case is just O1, and we only count for O log n. So yeah, so we're done with this problem. Thanks for watching. See you soon.